Hi, today we are going to learn about comparing numbers. Given a set of numbers, how do we find the largest and the smallest number from that set? What are the rules to compare numbers and why those rules make sense? We will learn all these through examples. So let's start with the first example. The problem is to find the smallest and largest number from the following numbers: 2853, 3590, 9999, 12002, and 124. So how do we go about finding the smallest and the largest number? The rule is really simple. We just count the number of digits in each number. And the smaller the number of digits, smaller is the number, which also means larger the number of digits, larger is the number. So let's find out the number of digits in each number. Let me start with the first number, that is 2853. It has units place, tens place, hundreds place, and thousands place. So total 4 digits. The next number also has 4 digits. The third number also has 4 digits. The fifth number, let's count the number of digits. Units place, tens place, hundreds, thousands, and 10,000. So it has total 5 digits. And the last number has 3 digits. So we see that this number has the largest number of digits and this number has the smallest number of digits. So 12,002 is the largest number and 124 is the smallest number. Wow, that was easy. But we should also have a doubt in our mind that what happens if number of digits is same for those multiple numbers. We don't know that yet. So let's continue with the same example. But this time let me strike out this number and this number. I'm also striking out the number of digits. And now the problem is to find the smallest and the largest numbers from the remaining 3 numbers. We notice that number of digits in all these numbers is same, that is 4. So how do we compare these numbers? So that's where the second rule comes in handy. When two numbers have the same number of digits, we start comparing the numbers from their leftmost digits. The number with the smaller digit is the smaller number. Conversely, the number with a larger leftmost digit is the larger number. So let's see what are the leftmost digits. For this number, 2 is the leftmost digit. For this number, 3 is the leftmost digit. And for the third number, 9 is the leftmost digit. And comparing 2, 3 and 9, we see that 9 is the largest digit and 2 is the smallest digit, which means 9999 is the largest number and 2853 is the smallest number. Okay, so let's take another example. So we want to compare two numbers, 7523 and 7548. So let's compare. Let's use the first rule. So let's count the number of digits. So this number has 4 digits, first number has 4 digits, and second number also has 4 digits. So we can't really compare the number of digits. Now let's go to the second rule. Let's start comparing the leftmost digit. So the leftmost digit for this number is 7 and for the second number is also 7. So both are same. We can't really compare. What do we do next? We move to the next leftmost digit, that is 5 in the first number, and the second number also has 5 in that same location. So we still can't compare the digits, compare the numbers. So let's move to the 10th place, and this time this number has 2 as the digit in 10th place, and second number has 4 in the 10th place. So 2 is smaller than 4 and hence 7523 is a smaller number and 7548 is a larger number. So let's summarize the rules for comparing numbers. The first rule is count the number of digits, and smaller the number of digits, smaller is the number. And when the two numbers have same number of digits, what we do is we start comparing the numbers from their leftmost digit. The number with the smaller leftmost digit is the smaller number. Conversely, the number with the larger leftmost digit is the larger number. So this is something to remember. One thing to note is that once we find the leftmost digit that differs, we don't go beyond that digit. We don't have to look beyond that digit. So why? We will come to that in a later slides. But these are the two rules to remember. If you have any questions about these rules or the examples so far, feel free to write it in your comments and we will answer them. So with these two rules, we now know how to compare numbers. So let's see whether we can apply these two rules in another example. So here is a similar example. We want to find the smallest and the largest numbers from the given set of numbers. So by looking at the numbers, we figure out that number of digits seem to be different for these numbers. So the first rule will come in handy. So let's first try to find out the number of digits in each of these numbers, and we can quickly write down the number of digits. The first number has 4 digits, second has 5, third has 3, fourth has 5, and fifth has 2 digits. So we see that second number has 5 digits and fourth number also has 5 digits. So that means the largest number has to be one of these two numbers. So now we have to compare these two numbers. So since the number of digits is same in both numbers, we will use the second rule, that is comparing the leftmost digit. So the leftmost digit for second number is 1 and the fourth number is also 1. So that doesn't tell us much about the numbers. So we'll move to the next digit. So that is the digit at thousands place. So the digit at thousandth place in the second number is 5 and the digit at thousandth place in the fourth number is 3. So this number is the largest number. This is the larger among these two numbers and it is the largest among all these numbers. So we know we found the largest number. What about the smallest number? So we look at the number of digits and this is the least number of digits. So 85 is the smallest number. So let's summarize this. So according to us, 15,691 is the largest number and 85 is the smallest number. But guess what? It's wrong. Why is that? If we take a closer look, we can see that 18 is also among these numbers and it is certainly less than 85. So we made a mistake. So what mistake did I do? So I can see that I counted 18 as a 3-digit number, which is wrong. 18 is not a 3-digit number because since it was written 018, I thought it is a 3-digit number. But if that is the case, we can write it as 0018 or 00018. So that would make this number as 4-digit number and this number as 5-digit number, which is clearly wrong. So something to remember is that the leftmost digit cannot be 0. So the valid leftmost digit has to be non-zero. But once we have the leftmost digit as non-zero, can we have later digits as 0? Yes, we can. So in this example, so 13,002 has later digits as 0 and that is perfectly fine. So that is something to remember, that valid leftmost digit has to be a non-zero digit. Let's continue with another example. The problem is to create smallest and largest 4-digit number using digits 8, 2, 5 and 0 without repeating the digits. So let's take a moment to understand the problem. We want to create smallest and largest 4-digit number using these 4 digits, and the constraint is we cannot repeat the digits. So let's start with finding the largest number. So since we want to create 4-digit numbers, all the numbers will have same number of digits, that is 4. So the first rule does not come in handy. So we have to rely on the second rule. And second rule says that we have to look at the leftmost digit, and the number with the largest leftmost digit will be the largest number. So out of those 4 digits that we have got, 8 is the largest digit. So let's put 8 in the thousands place. And since we cannot repeat these digits, I'll have to strike out 8 from the available digits. So for the hundreds place, what should be the digit? So from all the numbers that have 8 as thousands digit, then the number which has the largest digit in the hundreds place will be the larger number. So we have 2, 5 and 0 as available digits in hundreds place. We'll put the largest digit, that is 5, in the hundreds place, and since we cannot repeat it, I'll strike it out 5 as well. So for tens place, we have to put larger among the 2 available digits. So 2 is the larger, and I'll strike that out, and I'm left with 0 at units place. So 8520 is the largest number that I can create using these digits. So you can see a pattern in creating largest number, and the pattern is we arrange the digits in descending order, that is from largest digit to the smallest digit. So we started with 8, then we move on to 5, then 2 and 0. So that's the rule to create largest number. So you can imagine that for smallest number also we can use similar rule. We just have to make it opposite. So we'll start with smallest digit and we'll move on to the largest digit. So let me just clear these things and we will do it formally again. Okay, so let me remove this and let me start with the smallest digit. And from all these digits, 0 is the smallest digit. So let me put 0 here. But I remember that I cannot use 0 as valid leftmost digit. The valid leftmost digit has to be a non-zero digit. So I cannot use 0. I have to use from the remaining 3 non-zero digits and the smallest digit among the remaining digits. So from 8, 2 and 5, 2 is the smallest digit. So I'll put 2 at thousands place. And since I cannot repeat the digits, I'll have to scratch 2. Now at hundreds place, what is the digit should I put? So I have to put the smallest between the available digits. Can I put 0 here? Yes, I can, because once I have taken care of the leftmost digit, which is non-zero, I can use 0 in the remaining digits. So I'll put 0 in hundreds place and let me strike that out. For tens place, I have to put the smallest number, smallest digit among the available digits, so which is 5. So I'll put 5 here, I'll strike out 5, and now I'm left with 8, so I'll put it in the units place. So 2058 is the smallest number. And as we guessed, the rule to create smallest number is to arrange digits in ascending order, that is from the smallest digit to the largest digit. But there is a catch. You have to be careful with the zeros. 0 cannot occupy the leftmost digit. But once the leftmost digit is non-zero, then zeros can come afterwards. So that's something to remember. So let's continue with another example of similar kind. So this time the problem is to create smallest and largest 4-digit number using all the digits, that is 0 to 9, and repetition is allowed. Repeating the digits is allowed. So again, let's take a moment to understand the problem. So we want to create 4-digit numbers using digits 0 to 9 and repetition is allowed. So let's start with the largest number as usual. Largest 4-digit number we want to create. So we'll start with the largest digit available, which is 9. So I'll put 9 in thousands place. And should I strike 9? No, because since repetition is allowed, I can use 9 again. So for hundreds place, what should be the digit I should use? I want to use the largest digit. So I'll use 9 again. And at tens place, 9 again and 9 again. So 9,999 is the largest 4-digit number that I can create using all the digits. So let's go to the next problem, smallest 4-digit number. So here we know that we have to arrange the numbers in ascending order, that is increasing order. So let me start with the smallest digit. So I'll put 0 here. I know that I made a mistake here again. I cannot use leftmost digit as 0. So I'll have to use the next smallest digit at the in the leftmost position. So next smallest digit, which is non-zero, is 1. So I'll put 1 in thousands place. What about hundreds place? Shall I put 1 again? Because repetition is allowed. No, but I have 0 also with me. And since I have taken care of leftmost digit, I can use 0 at hundreds place. And what about at tens place? I can use 0 again and 0 again. So we have the smallest 4-digit number, which is 1000. So just remember that largest 4-digit number is 9,999 and the smallest 4-digit number is 1000. So let's say we want to create largest 3-digit number, and that would be 999. So here is something interesting happening. So it's interesting to note that the smallest 4-digit number is 1000 and largest 3-digit number is 999, and 999 plus 1 is 1000. Similarly, if I add 99 plus 1, I get 100. So 99 is the largest 2-digit number and 100 is the smallest 3-digit number. And 9,999 plus 1 is 10,000. So 9,999 is the largest 4-digit number and 10,000 is the smallest 5-digit number. So there is an interesting relation between the largest 4-digit number and the smallest 5-digit number, and largest 3-digit number and the smallest 4-digit number. So let's continue with this in the next slide. So we found something interesting in the last slide, and the takeaway is that the largest 3-digit number, that is 999, is just one less than the smallest 4-digit number, which is 1000. So 999 is close but still less than 1000. So largest 3-digit number is still smaller than the smallest 4-digit number. So no matter what 3-digit number is, it will be still smaller than any 4-digit number. Now you can understand that the number of digits really matter, and that is the rule 1. So any number with a smaller number of digits will be smaller than other number which has larger number of digits. And if you think a little bit, this also kind of explains rule number 2. So rule number 2 says that when the two numbers have same number of digits, the number with a larger leftmost digit will be the larger number. So let's take these numbers 999 and 1000, and I mean it's not correct, but let me write 999 as 4-digit number. So I'll put 0 at the thousands place, and we can see that if we have to compare these two numbers, we will look at the leftmost digit, and 1000 has the larger digit, which is 1. That is the larger number, and you can see that beyond this leftmost digit that differs, we don't have to look beyond it, because no matter what comes beyond is not big enough to replace the larger leftmost digit. So let me just summarize that. So once we find the leftmost digit that is different, we need not look beyond that digit, and that's because no matter what those digits are, they cannot make a bigger number than the bigger leftmost digit can make. Okay, so that kind of explains second rule. So with this, we have seen why these two rules also make sense. So that's all we have to cover in this chapter. So if you like this video, please subscribe to our channel to see similar videos. If you have any doubts or questions, please feel free to ask in the comments and we will answer them immediately. Thank you and see you again.